we created a couple of very useful constructors in our string. The default constructor and the specific constructor that takes pointer to a C string, which is 0 terminated. And Destructor is the opposite of constructor, and you can add Destructor to your C++ class. And Destructor is invoked anytime when object is going out of scope. For instance, just a variable goes out of scope, like for instance here, all of these local strings that we create in our function main will be destroyed before we leave the function. So before function main terminates, all of these string objects will be destroyed. So if you'd like to explicitly write a destructor, it looks somewhat similar to a default constructor, but it's using the tilde sign in front of it, in front of its name. Tilde was chosen to indicate that it's the opposite of the constructor, and it's still using the class name with the tilde in front of it. And tilde is, of course, a binary bitwise complement operator, which flips every bit in an integer or some other data type. So anyway, so this is the look and feel of a destructor. So let's write this up here, that this is our destructor. Now, unless you allocate resources dynamically, or unless you really want to do something special at the end of the logic cycle, life cycle, its life span, you really don't need the destructor. So we never had to add this destructor to our tests with string, because we need destructors only if our objects begin to allocate resources dynamically. Ideally, your constructor will allocate memory dynamically, and the destructor will return it back to the system. So let's think about an example when we would want to have a destructor. So let's just remember that we would like to add destructor to the string. But first, conceptually, and I can even remove it for now, but like I said, conceptually, we want to have a string, a Java-like string object behaving in our C++ application. So this could be useful for example, porting Java application to a C++ program. So let's add some comments to the class declaration right here. So this, for example, length returns the number of characters in a string, and the other function returns the character at the specific index. And what if now I would like to create a function which returns a substring? So again, I'm copying this from signatures of Java documentation, and substring in Java, a substring supposed to take an index of a character and return a substring, the fragment of the string, starting from this index to the end of the string. Okay, so of course in Java strings are constant, they're immutable. Therefore, a function such as substring must generate brand new string. It has to create a new string with the pointer to a set of characters that contain a specific substring. So this is why I'm also marking these functions as constant, because really the original string that we have should not be affected by someone calling a substring and generating a substring. Let me also give you a client view of this function call. I'll remove samples of dynamic string allocation for now, and just refocus on perhaps on this syntax. And we've figured the way to print these attributes of our string, like character and the length of the string. So it will just return 0 right here. But the new function which I'd like to explore is this substring. Okay, and we can start from character 7, for instance, right? So we want to generate a substring of the string starting from position 7, and this is position 7. So really, we just want to be able to extract this part of the string, which says world with an exclamation point. So like I said, it's very important that we must generate brand new string. Okay, so in Java, there is Java Virtual Machine, which allocates and deallocates new objects in Java Virtual Machine memory. In our case, we have to deal with dynamic memory and allocate resources accordingly. So let's try this. In C++, an equivalent of read-only string is called string view. It was added to C++ relatively late to the standard of C++, and this is one of the latest concepts that are available. You can go to Learn CPP and read this really good tutorial which introduces the basic functionality of string view, and it's very similar to string, standard string, but it manages a read-only string, eliminating any overhead that a string object has with respect to strings that could be modified. So string view expects that the strings will not be modified. So what I'm about to do is that I'm going to include this header, and then what I'd like to do is replace this pointer to string with string view. Okay, so I'm just going to get rid of this pointer to string and replace it with string view, and we will explore how the string view can do things for us. So of course we need to switch over to the implementation, and every time we use pointer to string we have to rethink how we do our work here in this implementation. And let's start from the bottom of this list of functions and constructors. For example, now that pointer to string is gone, we have a string view. So we can use a function named at, and it is very similar to the function or method rather of Java string character at. So same idea. Zero-based index and string view can return an index of a character. The length can be replaced by str view length, right? So it already has the length function built into it, and then of course this time it will encapsulate our string, and all we need to do is return this sub-object that we have, the string view, is delegate the work to its length. And when the string is constructed, our string object is constructed. So this is our constructor and constructor initializer list. Of course, string view has a very similar constructor that takes a pointer to a constant character, string of characters. So all we need to do is just replace this old pointer to string with the string view object constructor that takes this pointer. So not a very big change at all. And here, same thing, we just replace it. So now all pointer to string occurrences are removed, except of course this is here the same constructor that we used to support. So let's also get rid of this include. We no longer need to include this C-string header because we used it for string length before. So I will just for now remove this include. We'll bring it back if we need it for some reason. So I'm saving in the entire project right now, and you see that my client code really hasn't changed much. I'm expecting everything to work exactly the same way, except that of course we're going to try the brand new function substring of our string right here, which again we're just going to delegate to string view to do the work and return the character for us. So let's see if everything holds on together. I will try to build this. And the error message that I get at the top of this list right here is that string view is not a member of standard library namespace. So although I am including string view right here in the header of our string declaration, I'm still getting this message. So this is a bit frustrating and looks a little strange, but here's the helpful message right here. The contents of string view is available only with C++ 17 or later. And by default, unfortunately, this standard is not turned on automatically in Visual Studio 2019, perhaps because it's still considered to be not a complete or well-tested set of new functions or facilities, but there is an information how to turn C++ 17 standard available. So we need to go to our project properties, which we can do right here, project properties, and you can see this set of instructions suggests that we go to C++ section and the language and C++ language standard, which is right here. It's using default Visual Studio 2019 in my case. So we can switch over to 2017 standard right here and apply this and click OK. And also, of course, after changes in project settings like this, I would definitely want to be able to clean all results of previous builds. And so with this now try to build again. And this time I'm only left with the message that basically says that there is no such function really defined. It was declared function, but it was not defined. So basically we need to generate a appropriate code to be able to accommodate this substring results, which would make a copy of the string. So we can switch over to our implementation file, string.cpp, and add this brand new operation. Immediately delete semicolon right here, and also prefix the name of the function with the scope of our string class. And now all we have to do is basically from here we need to return a brand new string. Okay, so we will construct brand new string, and from there we will take our string view, which is encapsulating our constant string, and the corresponding function in string view is substr. Okay, substr. And what we need to pass to the substring function is the same parameter. It's very, very similar to Java version right here, right? So Java version of a substring passing the index in string view implementation that we're trying to use right here, and we're creating this object. The substring should give us the same exact result. String view substring function returns back a copy of string view. So what we must do is, apparently, to construct the string we have to add another constructor, I would think, which would take as a parameter a reference to string view, and make it a constant reference to string view. When we finish this set of coding modifications, I will demonstrate everything that happens in computer memory. So let's just say that for now, this type of constructor of our string will be accepting a reference to another string view somewhere in computer memory, but will not attempt to make a copy of that string view. We'll be able to access the original object. So let's copy this constructor to our implementation file, immediately get rid of the semicolon, of course add appropriate scope resolution in front of the name of this new constructor, and can copy the same implementation of a constructor into this new constructor and simply construct our string view object inside of our class string by making copy of another one somewhere else in computer memory. So at this stage we can try to build this application, but I'm still expecting that we will not be able to bring string directly to the cout. We may need to first provide this overloaded operator so that the substring returns a copy of a string class object, and therefore cout will probably not be able to understand how to print the result of the substring, because once again our substring returns copy of the string, and so we need to provide an overloaded operator, output operator, to be able to accommodate, to make cout happy with the result of our substring.